In this video, I will introduce a paper about biomechanics of bench press. But before I talk about the paper, I'd like to share the research question of this study. The bench press exercise is one of the most effective upper body strength training exercises. And the bench press can be performed with different variations, such as different speed of movement and different grip width, depending on the goal of the exercise. So, there have been many studies that examined the effects of different speeds and grip width on biomechanics of bench press. However, there was a common methodological issue in the papers. Self-selected speed and grip width have not been considered by many of experimental previous studies. Also, when I was conducting deadlift research, I tried to control the speed of deadlift motion using a metronome to minimize confounding factors coming from the discrepancy in movement velocity between two deadlift conditions. But the participants reported discomfort when they were experimentally controlled during the deadlift. So here were research questions of this study. And the title of this study was a biomechanical comparison of self-selected and experimentally controlled speeds and grip width during the bench press exercise. Okay, what is the bench press? The bench press exercise is an upper body strength training exercise. So lifters lying down on a bench lower the bar to touch the chest at nipple level and push the bar upward and slightly backward until the elbows are fully extended. There are two primary variations of the bench press: speed of movement and grip width. A different speed of movement can change muscle activity during the bench press. This speed variation may be due to targeting different training goals. For example, a slow speed has been recommended for technique acquisition, and then fast speed has been shown to produce better improvement in strength and more repetitions. And different grip width can also change muscle activity and one repetition maximum during the bench press. For example, 1 RM increased as grip width increased up to around 200% of biacromial distance. There were common methodological issues in the previous bench press studies. Self-selected conditions have not been considered by many of the experimental previous studies. In the experimental conditions of the speed of movement and grip width during the bench press, a metronome was used to control the speed of movement, and then the biacromial distance was used to control the grip width during the bench press. In addition, the participants reported discomfort under experimentally controlled conditions during resistance exercise. So the purpose of this study was to compare 1 RM and a rating of discomfort and EMG activity of the upper body between experimentally controlled and self-selected speeds and grip width during the bench press. And 20 skilled participants were used for this study. Then they had at least 3 years of bench press experience. And for trial conditions, 1 RMs were measured 1 week prior to actual data collection. And then there were 4 bench press conditions in this study: self-selected speed and grip, SS condition, and self-selected speed and experimentally controlled grip, SC condition, and experimentally controlled speed and self-selected grip condition, CS condition here, and experimentally controlled speed and grip width condition, the CC condition. And then the control speed was determined for each participant based on their self-selected speed measured during the 1 RM testing as self-selected grip width. The 1 RMs of SS, SC condition were first measured, and those of CS and CC were measured afterward. And 3 bench press trials were performed with 80% of 1 RM for actual data collection. For the controlled grip width condition, 200% of biacromial distance was used. And for the controlled speed condition, the tempo of 2 beat down and 2 beat up was used for this study. So the time measured in seconds during the 1RM testing was converted to beats per minute using this equation. 4 beats were first divided by the time measured in seconds to calculate the beats per second. And the beats per second calculated was then multiplied by 60 to convert it to BPM. For experimental setting, Norexon electron myography was used to measure myoelectric activity of 4 muscles. So pectoralis major, and then thoracic brachii, anterior deltoid, and biceps brachii. And 2 markers were attached to the bar. The Vico motion capture system was used to capture the bar movement, and quantitative XP was used to calculate vertical acceleration of the bar. For data analysis, submaximal voluntary dynamic contraction, which was 90% of one repetition maximum, was collected to normalize raw EMG value. And filtering, rectification, and smoothing were performed for EMG signal processing. And upon the completion of 1RM measurement, all the participants were asked to answer the question of what was the most uncomfortable condition among the 4 bench press variations. And these questions was asked to identify a rating of discomfort. And a vertical bar acceleration was also calculated to explain the result of this study. Statistical analysis. For EMG activity, a two-way repeated measures of MANOVA was performed. And independent variables were speed and grip width. And dependent variables were EMG activities of the muscles. And for 1RM, one-way repeated measures ANOVA was performed. An independent variable was a type of bench press, and dependent variable was 1RM. Frequency analysis was also conducted using participant response to the question about a rating of proportion of participants selecting one condition as the least comfortable bench press condition. Okay, the result of this study. Let me explain this graph first. The left vertical axis means the one repetition maximum. The right vertical axis means a rating of discomfort. And then black bar graph represents 1RM. And gray line graph with dots stands for a rating of discomfort. And SS showed a significantly higher 1RM than SC, CS, and CC conditions. And in terms of rating of discomfort, CC was characterized as the most uncomfortable bench press condition, followed by CS, SC, and SS condition. In terms of EMG activity, there were no significant main effect and interaction of speed and grip width condition on the muscle activity. It was also observed that the self-selected grip width was significantly narrower than the controlled grip width. Discussion. The red box here, this is a self-selected speed conditions. And green box here, this is a controlled speed conditions. For both speed conditions, the participants showed a higher 1RM at the self-selected grip than at the controlled grip on average. This result was comparable with the previous study that compared the 1RM measured using different grip widths, such as close, medium, wide, and self-selected grip width. And the study reported that the medium grip width showed similar 1RM value to self-selected grip condition, whereas medium grip showed significantly higher 1RM compared to close and wide grips. This previous study speculated that the higher 1RM observed during the medium grip condition may be caused by a superior mechanical advantage allowing higher contribution of pectoralis major muscle. And this time, the red box is a self-selected grip, and then green box is controlled grip. For both grip conditions, the participants showed a higher 1RM at the self-selected speed than at the controlled speed on average. This result is likely to be due to the fact that the control speed could inhibit participants from performing a natural barbell vertical movement, since tempo was controlled. As I mentioned earlier, this study also analyzed vertical bar acceleration. So this graph is describing the vertical bar acceleration, which shows the natural vertical movement of the bar. So here, black solid line means SS condition, then black dotted line means SC condition, and gray dotted line means CS condition, and gray solid line means CC condition. First of all, this vertical bar acceleration can be broken down into 5 phases: so unweighing and constant acceleration and deceleration acceleration. This one occurred around the bottom of the bench press. And then another constant acceleration and unweighing condition. And first unweighing here occurred due to the speeding up in the downward, and then constant acceleration, and then deceleration acceleration occurred due to slowing down in the downward and speeding up in the upward around the bottom of the bench press. And then second unweighing, this condition occurred due to slowing down in the upward movement. So based on this graph, SS and SC conditions showed greater unweighing in the beginning and end of the movement, and also greater deceleration acceleration around the bottom position compared to CS and CC conditions. And the discussion of rating of discomfort. So we can take a look at just this gray line graph. 80% of total participants expressed the most uncomfortable condition when both speed and grip width were controlled. And this result can be attributable to the fact that controlled condition inhibited a natural vertical barbell movement. In other words, the controlled grip did not provide an optimal grip width, and the controlled speed did not provide a natural speed during the bench press. In terms of EMG result, there were no significant main effect and interaction of speed and grip width on EMG activities. It may be due to the fact that the effects of grip difference on EMG activity was marginal between self-selected and controlled grip conditions in this study. And also, the control speed was determined based on their self-selected speed conditions measured during the one-item testings. So, the speed difference were also likely to be insignificant between the self-selected and controlled condition. So conclusion, based on the findings of this study, the SS condition showed the highest one-item value, and then the participant felt more uncomfortable during the controlled bench press condition than during the self-selected ones. And this study also suggested that the result obtained under experimental controlled condition in resistance exercise research should be carefully applied to the real world. These are all references for this study. Thank you for watching this video.